Today we will look at parallel circuits. What is a parallel circuit? In a parallel circuit, there are more than one way for electrons to flow. So if we think back to the series circuit that only had one way for electrons to flow, the parallel circuit has multiple ways for electrons to flow, depending on how many loads there are. Remember, a load is like a light bulb. So in this circuit, the electrons can flow, well, it's going to go from the negative terminal, and it's going to come around and go through this light bulb, or it could come around and go through this light bulb, or it could come around and go through this light bulb. So there's three different ways for electrons to flow. So they have very different properties than series circuits. An analogy for a parallel circuit is a city block. So just like there are multiple ways for the vehicles to go in this block, as opposed to the racetrack analogy for the series circuit, there are multiple ways for the cars to go. In a parallel circuit, there are multiple ways for electrons to flow. So what are some properties of a parallel circuit? If one bulb goes out, the rest stay on. So if you think about maybe your Christmas lights, if one of them burns out, the rest of the string will stay on. It used to be different. They used to be wired in series, so if one went out, they all went out, and it was very challenging to figure out which bulb was out. So it's very good that they now wire them in parallel. Another property of a parallel circuit is that the current leaves the source and is split up and shared with each load. So in that case, the brightness does not change because of this. So they all get an equal amount of power from the battery. And another property of a parallel circuit is you can turn off just one load, which is very useful in some of the applications that we use parallel circuits, such as our homes. So we use parallel circuits to wire our homes, which, if you think about it, makes sense, because if you turn off the lights in your kitchen, it doesn't mean your fridge and stove turns off or your microwave. So our homes are wired mostly in parallel circuits. Cars are also wired in parallel, which means that there are many, you could turn on the lights in your car even if your car isn't actually on. So there's multiple ways for the energy from the battery to travel in a car. Computers are the same. They're also wired in parallel. So your challenge this week is to build a parallel circuit with two bulbs, closed switch, a battery, and wires, and then make the light bulb light up again. Your second challenge will be to draw what you've built. So you can go to class tools and assignments and find your challenges for this week. Have a good week.